Hi, I'm Paul Keoghan from GK Tuition, and in this video I want to go through an exam question from 2017 paper 1, and it's question 7 that we're going to talk about. Now, in this question we're told that the future population of a city can be predicted by using a formula, and the formula or the equation for Sapphire City is that P of t is equal to S times e to the power of 0.1 t by 10 to the power of 6. Where P of t represents the population, t represents the time, and s is a constant. Now we're told that t equals 0 is in 2010. So this scenario starts in 2010. In 2010, t will represent 0. Now, I'm told for the first part of the question, I'm told that the population of Sapphire City is 1.1 million in 2010. So that tells me that t equals 0 and that P of t is 1.1 million. So in an exam question, the first thing I'd do is I'd write out my equation. Then I'd write out the information I was given, and then I'd sub in. So you'll notice that I've already gone through this question. Instead of P of t, I subbed in 1.1 million, and instead of t, I subbed in a 0. So on the next line, I have e to the power of 0. Any number to the power of 0 is just a 1. And I've divided both sides by 10 to the power of 6, which means the 10 to the power of 6 is gone from the right, but I'm dividing it on the left. Then 1.1 million divided by 10 to the power of 6 is 1.1. So the answer to my first question is just 1.1. For the second part of this question, we're asked to find the predicted population in 2015. So you should recognize that 2015, that means that t is equal to 5. Now in part A of the question, I worked out that s was 1.1. So you'll notice that I've changed my formula here. S is a constant, which means my formula has changed and I can sub in 1.1. So now in my formula I only have two unknowns. So if they tell me t, I can find P of t. So they've told me that t is equal to 5, which means my only unknown is the population. So I can just sub into my formula. Instead of a t, I can sub in a 5. And your answer works out as 1813593.398. But obviously this represents population. This represents the number of people in a city. So your answer should be to the nearest whole number. So in this case, because it's 0.3, we round down to 1813593. Okay, so my population in 2015, the predicted population is this. For the third part of this question, we're asked to work out the predicted change in population in 2015. So in order to do that, we're going to try and work out what is the population in 2016, at the start of 2016, and also we're going to find the population at the start of 2015. And clearly the difference between the start of 2016 and the start of 2015, that will be the increase in population, the change in population over the course of that year. So we just need to sub in t equals 6 and then sub in t equals 5 and subtract our two answers. Okay, so once we do that, we just sub in t equals 6 to find the population at the start of 2016. We sub in t equals 5 to sub in this population at the start of 2015. You get 190,737.2. So clearly your answer is 190,737. Okay? Now I'm sure there's a lot of you watching this video and scratching your heads a little bit. In the previous question, we worked out the population at the start of 2015. But we rounded off marginally. We rounded off a little bit. So if you just got the population at the start of 2016 and then subtracted your answer from part B, because you had rounded off, your answer would have worked out as 190,737.68, which I'm sure means you would have rounded up to 38, which would have been incorrect. So if you used your answer from part B, it was less accurate and you actually ended up with the wrong answer in this case. So always go back and be as specific as possible. So to get the right answer, this time you had to actually work this out again. Work it out where you haven't rounded it off. So you sub in t equals 6, you sub in t equals 5 and subtract them. It actually works out as to 0.2, which means you're rounding down. So I think that year in 2017, a lot of people ended up with 738 rather than 737. So if you can at all, just be as specific as you possibly can in these questions. For the fourth part of this question, we're moving now to Avalon City. The predicted population of Avalon City is given by this formula. I'm told that in 2011, the population of Avalon City is 3709795. So remember, 2011 means t equals 1, and q of t is my population. So if I know q of t and I know t, I'll be able to work out my k. The question says to write out an equation to show that k is minus 0.05. So again, the first thing you do is you write out your formula, you write out the information you've been given, and then you do your substitution. So at this point now, we can simplify this down to try and find our k. For the moment, we'll leave the left-hand side as it is, but on the right-hand side, we should multiply 3.9 by 10 to the power 6. Remember, 10 to the power 6 is just a million. So 3.9 by 10 to the power 6 is just 3,900,000. And that's e to the power of k. Now, you should recognize that your unknown is in the power. If your unknown is in the power, you're going to have to introduce logs. So the only way we're going to be able to find our k is if we introduce logs. But a very common mistake is that a lot of students introduce logs now. But this is too soon. Once you've identified that you want to introduce logs, you want to isolate the term that has your unknown in the power. So I want to isolate e to the power of k, which means I'm going to divide both sides by 3.9 million. And my left-hand side will just be 3709795 over 3.9 million. But my right-hand side is just e to the power of k. Now that I've isolated this, my unknown is in the power, so I'm going to introduce my logs. So what that means is it literally just means you're putting ln in front of both sides. So you just rewrite both sides except with an ln in front of it. So if I just put ln in front of the left and ln in front of the right, that's my logs introduced. Now the reason we've introduced logs is because now we can apply the rules of logs. The rules of logs are on page 21 in your log tables. If you go to the middle column on page 21 in your log tables, it tells me that if I have log of something to a power, then I can just bring the power in front. So to simplify this down, my right hand side just becomes k times ln e is equal to ln 3709795 over 3.9 million. Okay, now remember that ln e is just 1. So if ln e is just 1, I can actually just put in a 1 there. So ln e is just 1, which means k is equal to this. So to get your value of k, you just sub it into your calculator. If you plug that into your calculator to 2 decimal places, you work out that k is minus 0.05. Now, because it actually gave you the answer and asked you to prove that, make sure you conclude. So just put a tick beside it and say that it's true. Just a small conclusion at the end to show that you've verified what you were asked to verify. In part E of this question, we're asked to find the year in which the population of both cities will be equal. Okay, so clearly that means I want to know when is the population of Sapphire City equal to the population of Avalon City. So I'm going to let each of my equations equal to each other. Now you'll notice that I've an equation here and I've got only one unknown. My only unknown is t. So if I have one equation and one unknown, I'll be able to solve it to find the value of t. So first of all, I'm multiplying both sides by 10 to the power 6. So they're just going to cancel each other out. So now I have 1.1 e to the 0.1 t equals 3.9 e to the minus 0.05 t. So probably the easiest thing to do here is bring all my t's to the left-hand side and all my numbers to the right-hand side. So if I wanted to bring my e to the minus 0.05 t to the other side, I just want to divide both sides by this. If I divide both sides by this, I'll get 1.1 e to the 0.1 t over e to the minus 0.05 t is equal to 3.9. Okay? But actually on that line as well, we can do something else. We can also divide both sides by 1.1. If I divide the left by 1.1, it's gone from the left, and there's a 1.1 on the bottom on the right. So all I've done there is I've brought this underneath, and I've brought my 1.1 underneath on the far side. At least now I have all the t's on the left and all the numbers on the right. Now I can use one of my rules of powers to simplify the left-hand side. One of your rules of powers from page 21 on your log tables is that a to the power of p over a to the power of q, if you've got something to a power divided by something to a power, you can just subtract the powers. It's just a to the power of p minus q. So I can just do that here. I have e to the power of something over e to the power of something, so I can just subtract my powers. So it just becomes e to the power of 0.1t minus 0.05t. Okay? And my left-hand side for the moment, let's just leave it as it is. 0.1 minus 0.05. Well, minus by minus is a plus. So I actually get 0.15t is equal to 3.9 over 1.1. And now this is very similar to part D. My unknown is in the power. If your unknown is in the power, you have to introduce logs. I've already isolated the term that has an unknown in the power, so I can actually introduce logs on this line. So what that means, I'm literally just putting ln in front of both sides. So it's ln e to the 0.15t equals ln 3.9 over 1.1. Now I can use my rules of logs. So again, your rules of logs are on page 21 in your log tables. And the third rule of logs says that if you've log of something to a power, you can just bring the power in front. So let's continue this one over here. So all I have to do is bring my power in front. So it's 0.15t times ln e is equal to ln 3.9 over 1.1. Now ln e is just 1, so I can actually ignore it for the moment. And if I'm trying to find t, I just want to divide both sides by 0.15. So I get my right-hand side becomes ln 3.9 over 1.1 divided by 0.15. And if you plug all of that into your calculator, you end up with t is equal to 8.44. So now just be very careful and double check what the question asked. So the question asked me, during which year is the population in both cities the same? So I know it's when t is equal to 8.4. So it's about halfway through the 8th year. I know that t equals 0 is 2010, which means t equals 8 is 2018. So it's about halfway during 2018 in which the populations of the two cities will be the same. So your answer in this case is 2018, so the year 2018. Okay, so I hope all of that makes sense. Okay, so for the next part of this question, we're asked to find the average predicted population in Avalon City between 2010 and 2025. Now you should recognize the function q of t describes the predicted population in Avalon City. So I know my function q of t. And if I want to find it from 2010 to 2025, well, 2010 is t is equal to 0, and 2025 t is equal to 15. Clearly 15 years after t equals 0. So you should recognize that this is an integration question. I want to find the average of this function when subbing in my values from t equals 0 to t equals 15. Now there's a formula in integration for this. So I want to sub into my average value formula. My average value formula from integration is 1 over b minus a times the integral of the function. Okay, where b and a are the limits that you're going to use. So this formula allows me to find the average of a function across a range of different values. In this case, a range of different t values. So clearly in this case, my lower limit is going to be 0, my upper limit is going to be 15. So I can just sub in and integrate this. So 1 over b is equal to 15 while a is 0. So it's 1 over 15 times the integral from 15 to 0 of 3.9 times e to the minus 0.05t by 10 to the power 6. Again, notice that I'm putting in a dt at the end. It's just part and parcel of my symbology for the integration. So because I'm integrating, I should just have a dt at the end. Now, straight away, you should recognize I'm not going to integrate my 3.9. I'm not going to integrate my by 10 to the power 6. So these are just numbers, so I can take them out. 3.9 multiplied by 10 to the power 6 is 3.9 million. And I can take that 3.9 million outside. So my fraction outside here is just 1/15th. And then 3.9 by 10 to the power 6 is 3,900,000. Because it's a number, I can take it outside the integration sign, which means it's 1 over 15 times 3,900,000. And then I'm going to integrate e to the minus 0.05t. And my limits are from 15 to 0, and after that I'm going to put in a dt. So really all I've done is simplify this down a little bit. I've just taken the numbers outside the integration sign. Now the next thing I can do is 1/15th by 3,900,000 is 260,000. So it's actually just 260,000 times the integral from 15 to 0 of e to the minus 0.05t dt. So all of a sudden, I've just simplified down, but this line is a hell of a lot more straightforward than what I had at the start. So if you want to just pause the frame here, I'm going to continue this one from the top. Okay, so we left off at this point, and in the next line now I'm going to integrate. So I can leave the 260,000 outside. The integral of e to minus 0.05t, well, it just stays the exact same. It's e to the minus 0.05t, and then you divide by the number in front of your t. So I'm going to divide by minus 0.05. Okay, and because I now have to apply limits, I'm going to stick in square brackets around that. So square brackets around it because I need to apply limits. My limits are 15 to 0. So in this case now, all I have to do is sub in my limits. So it's going to be 260,000, and now I'm going to open a bracket. To apply my upper limit, just everywhere there's a t, I'm going to sub in a 15. So I'm just going to rewrite this, except it's e to the minus 0.05 times 15, and all of that divided by minus 0.05. So that's my lower limit. Now that's my upper limit. But now I need to sub in my lower limit. Before I do that, I need to put in a minus between them. So I plug in my upper limit and then subtract my lower limit, which in this case will be e to the minus 0.05 times 0 divided by minus 0.05. And I can close my brackets. So it's 260,000 times this. And again, notice that these are all numbers. So at this point, I just plug all of that straight into my calculator. And when you plug all of that into your calculator, your answer works out as 2743693.9. Remember, I'm working out the average population in Avalon City between 2010 and 2025. So obviously, I'm talking about a certain number of people. It doesn't make sense to have 0.9 at the very end. So I need to round this off to the nearest person. Clearly, if it's 3.9, I should round up to 4. So my final answer is 2743694. So the average predicted population in Avalon City between 2010 and 2025 is 2,743,694. Okay, the final part of this question, we're asked to find the predicted rate of change of population in Avalon City in 2018. Okay, so if it says 2018, you should recognize this t equals 8. They've told me that I'm using the formula q, the function q of t. And they've asked me for the rate of change. The rate of change in this context means find the first derivative. Rate of change is, the first derivative always tells me my rate of change. So if I get the first derivative and sub in t equals 8, that will tell me how much the population changes in 2018. So as always, before we differentiate or before we integrate, we should try and simplify down first. So I can multiply 3.9 by 10 to the power of 6. 3.9 by 10 to the power of 6 is 3,900,000. And then I just have an e to the minus 0.05t. Now that's my function, and now I want to get the derivative of my function, which is q dash t. The only bit of this that I can actually differentiate is my e to the power of minus 0.05t. If I want to differentiate e to the power of something, it just stays the exact same. So it's e to the minus 0.05t multiplied by the derivative of the algebra. So the derivative of my power. So I've got my power is minus 0.05t to the power of 1. So if you imagine the power of your t comes in front, so it's 1 by minus 0.05, which is minus 0.05, then the power of t decreases by 1 and it's gone. So the derivative of this is just this. And then I can just leave my 3,900,000 out here, because there's nothing that I can really do with that one. So that's my derivative, and to be honest, there's no point in simplifying any further, because all we need to do now is get the derivative when t is equal to 8. So I can just rewrite this line, except everywhere there's a t, I'll just sub in an 8. So it's e to the minus 0.05 times 8 multiplied by minus 0.05. And if you plug all of that into your calculator, your final answer is minus 130,712.4. Now obviously, again, we're dealing with population, so I have to round to the closest number. So it's minus 130,712. So I know that the population of Avalon will decrease by 130,712 people in the year 2018. Okay, so again, I hope all of this video made sense. If anything is unclear or if there's anything you're unsure of, just let me know in class during the week or send me an email and I'll hopefully be able to explain it differently.